All right, we have this proof, and you can see we have this figure with all these angles, right? And your alarm bell should be going off saying, I can apply angle adpos to these angles. And then we have this given that dB bisects angle ADC. This is the first time we see this, right? So what this means is that ray dB is an angle bisector of angle ADC. Okay, that's what it means. And so now you have to think, okay, well, what's the definition of angle bisector? Well, an angle bisector splits an angle into two congruent angles. So if we have this angle here, and this one's 20 degrees, and this one's 20 degrees, well, then that means that this ray is the angle bisector of the angle, right? Because it splits the angle into two congruent angles. So it's saying that dB, this here, is our angle bisector of ADC. Okay. So what does that mean? Well, if you think of ADC as a pie, right, a piece of pumpkin pie, and the dB is the angle bisector, meaning it's the knife that is cutting the piece of pie into two exact same size slices. That's what an angle bisector is. So what can you say with angle bisector? Well, if we look here, definition of angle bisector. If it's an angle bisector, then you could say the first angle is equal to the second angle. All right, so left side equal to the right side. The two slices of the pie are equal to each other, is another way to think about it. So let's go ahead and start by saying dB, the ray dB, bisects angle ADC. Number one is given, and now we're going to go ahead and use this, turn him into an equation using the definition of angle bisector. So it's 2. What's the equation that we can create if dB is the angle bisector of ADC? Well, it's that the two pieces of the pie are congruent, right? We could say measure angle ADB is equal to measure angle BDC, right? But if they give you a number in the vertex of the angle, it's easier to use the number. All right, so let's go ahead and say measure angle 1 is equal to measure angle 2. And then that's number 2 is definition of angle bisector. All right, so we take this statement, we turn him to an equation. That's always going to be a definition. Right? You say statement to equation, it's definition. Or equation to statement, also always a definition. So what are we going to do now? Well, we could do angle adpos and do all this crazy stuff to create some more equations, but it's not going to lead you down the right path. Okay. What we want to do now is we want to look at angle 1 and angle 3. Angle 1 and angle 3. Angle 1 and angle 3 are special angles. Look at them. Identify it. What are they? Well, if you said vertical angles, you're right. Okay. So what are vertical angles? They're created by two intersecting lines. So if we have these two intersecting lines, this angle and that angle are vertical angles. This is angle 1, this is angle 3 down here. And what do we know about vertical angles? Well, according to the vertical angles theorem, vertical angles are congruent. So that's what we're going to say next, is measure angle 1. Well, I mean, in actuality, you really should say angle 1 congruent to angle 3, but I'm just going to go ahead and skip forward and say measure angle 1 is equal to measure angle 3, and then our reason is vertical angles theorem. Okay. Oh yeah, you just came. I just noticed that my handwriting's horrible, so please excuse me. So anyhow, we have angle 1 is equal to angle 2, and measure angle 1 is equal to measure angle 3. Yeah, so what we could do is we could do substitution, right, to get to 2 is equal to 3. We can go ahead and take this 2, measure angle 2, and we could put it anywhere we see measure angle 1, right, in a different equation, right? Substitution only works in other equations. So we look here, do we see a measure angle 1? Yes, we do. So instead, I could put a measure angle 2 there. So that's 4 is measure angle 2 is equal to measure angle 3, and that 4 is going to be substitution. And then lastly, we want to convert back to congruency, so it's going to be angle 2 congruent to angle 3, and of course, its definition of congruence, right? Congruent angles. Okay, so another way this could have went is up here, we could have went angle 1 congruent to angle 2. Okay, so we could have a congruency statement. Let me go ahead and write it down. Angle 1 congruent angle 2. And then with the vertical angles theorem, we could have had a congruency statement, angle 1 congruent angle 3. Right? And then now we have 1 congruent to 2, 2 congruent to 1, and then 3, how does this go? So 2 is congruent to 1, oh yeah, right, and 1 is congruent to 3, right? So this is transitive. We could go straight to this step here. 2 is congruent to 3 by reasons of transitive. Right? And you can kind of think of transitive as being a substitution version for congruency statements. But anyhow, we have a lot of experience using measures and equations. So I suggest you stay away from using transitive on congruency statements and just go with the algebraic method that we talked about and we're very familiar with to get to our congruency statement.